In this video, I'm going to take an example so that we can understand the base rule better. So here is an example. In a sample of students, 60% of the students are from school 1, 20% of the students are from school 2, and rest 20% are from school 3. The probability of a student failing in this school are 30%, 40%, and 50% respectively. If you pick a failed student randomly, then what is the probability that he belongs to school 2? So we have been given two informations. Well, we have been given that from the sample, if you choose a student randomly, 60% chances are that he's from school 1, 20% chances are that he's from school 2, and 20% chances are that he's from school 3. Another type of information that is given to us is the failure percentage in school 1 is 0.3, the failure percentage in school 2 is 0.4, and the failure chances in school 3 is 0.5. So what we have been asked is find that the probability that the student who has been chosen randomly from the sample belongs to school number 2, given that we have chosen somebody from the group of failed student. So the conditional probability of a student belonging to school 2, given that he is a failed student. So the condition is that he is a failed student. Now we have this following information in front of us. So how do we calculate this probability? We'll use the Bayes rule for that. So the probability, or the question that is in front of us, is to find probability that the student randomly chosen belongs to school 2, given that he's from a group of failed students. We'll use the Bayes rule. So Bayes theorem, or the Bayes formula is like this. Probability of EI given an event A is nothing but probability of EI, and then probability of event A given EI. Now you see that this conditional probability is exactly opposite as this conditional probability, right? So we know what is the probability of failed given school 1, given school 2, and given school 3. That means we have been given this one, we have been given this portion, and then we also have all these things, and then we simply have to put the values and get the answers. So when we consider S1, S2, S3, school 1, school 2, and school 3 as EI, and the event A is nothing but whether somebody has failed. So the event A is failed, so we denote it as F, and the schools are S1, S2, and S3. Now put that in formula. So probability of S2 given F is probability of S2 multiplied to probability of F given S2. So S2 means school 2, right? So we have this value in the previous slide. We have this value, probability of S1, S2, and probability of S3. So probability of S2 and the probability of F, that means failed, given S2. That's also given. Probability of F given S2, which is 0.4, right? So all these informations are given. And in the denominator, we have the summation of that. Summation of probability of S1 multiplied to probability of failure given school 1. Similarly for school 2, and similarly for school 3, right? So we put all these values. So P of S2 is taken from the previous slide, which is 0.2, and then P of F of S2, given S2 is 0.4. So in numerator we have 0.2 multiplied to 0.4, right? Similarly for other terms, we have just put the value from the previous slide. So it's 0.6. Probability of somebody directly picked from school 1 is 0.6, because 60% of the students have taken from school 1, so it's 0.6. And then the probability that somebody is failing in school 1 is 0.3. We multiplied that. Similarly we do that for school 2, and similarly we do that for school 3. So that's the total probability in the denominator part. And then this is the conditional probability in the that somebody is from school 2 in the numerator part. When we divide this, we get a number called 0.22. So probability that if you randomly choose a student from the group of failed student, he belongs to school 2 is 0.22. So that's how we compute the conditional probability from the set of from the given problem using Bayes rule.